Great, thank you, Sam. Welcome. We're so excited to have you all here, and so excited also to be introducing this really critical open innovation challenge focused on detecting lead service lines without breaking ground. We have participating here in our panel, we have Nia Dreyfus from the City of Cleveland Division of Water. We have Jeff Bernowski from the City of Akron. We have Bill Birch from the City of Sandusky. And we have Verna Arnett from the City of Cincinnati. Also participating in this challenge overall is the City of Conneaut and Aqua, Ohio. These are all utilities that are partnering with us at the Cleveland Water Alliance to really focus on this important challenge. It's something that's facing utilities across the country and has a very high interest for innovators that can help solve this problem. Next slide, please. Cleveland Water Alliance has a number of programs. This year is one of our key programs, which is focused on opening up innovation with the push and sponsorship of industry players. We've actually launched 2 open innovation challenges for 2021. And the unique thing about these challenges is that not only do we lay out what that challenge statement is and what the criteria includes for helping to solve it, but we also are providing opportunities to actually test and validate those technologies in partnership with our industry sponsors. Next slide, please. So I'm going to kick this off by turning this over to Nia Dreyfus to kind of lead us through the background and focus here. Nia, will you take it from here?
Sure, thank you, Evie. Good morning, everybody. My name is Nia Dreyfus. I am the lead program manager for Cleveland Water here in Cleveland, Ohio. And first and foremost, I just want to say thanks to Cleveland Water Alliance for this opportunity to participate in a very necessary need that we have to help us in the water industry. So talking about lead and lead service lines, most recently, Flint, Michigan, and the incidents that happened there brought lead and lead service lines and water quality back to the forefront. Across the country, our water service lines, we have aging infrastructure. And recently, there has been a new requirement to the federal lead and copper rule, adding some additional rules and requirements for how we handle lead service lines and the inventory of all different kinds of service line materials throughout our utilities infrastructure. As far as the lead and copper rule is concerned, a new rule was published this past January. It's gone through some additional review, but it will be effective as of this summer in June. And then actually there's a possible pushback date till I believe September, but the compliance date for this new rule is 3 years from now, which is in 2024, which seems like a long time away, but really in terms of creating additional or meeting compliance for some of these additional requirements, it isn't that far away. So one of the rules or requirements is to complete a complete service line inventory for a utilities distribution system. And that accounts for not only the city-owned portion of a service line, but also the customer-owned portion. And there's a requirement to identify material, which can include lead, copper, galvanized, and possibly some other materials. A challenge that often utilities face is not really having an understanding of what's in the ground. There's a pretty good indication of potential likelihood for different materials based on the age of the service lines, age of the home, other factors, but sometimes records are missing. So aside from actually digging up into the ground, which can be very costly, time consuming, and often utilities don't have all the resources to get that done in a timely manner, we are hoping with the aid of this project through CWA, to focus on innovation and how we can change how we're able to tell what the materials of those pipes are. Next slide, please. So what are we looking for this particular project? So we're actually seeking out physical technologies. I want to make that very clear. I understand related to the industry, there are a couple technologies right now that focus on statistical analysis and AI prediction methods. We are not looking for that as a primary focus for this contest. We're actually looking for a physical detection technology that either can detect a service line through various types of ground or substrate, or by accessing a curb stop valve. So lead, obviously lead detection is a primary focus for this project, but additionally of interest are being able to detect copper and galvanized steel. Specifically with a note about galvanized steel, with the new lead and copper rule, there is a special distinction and requirement for utilities to identify galvanized service lines that are downstream of lead service lines. So there is a distinction, you have to break that apart. Service lines, they're typically up to 2 inches in diameter. Lead specifically is usually up to 1 inch in diameter. As far as what these lines look like and where they're at, lines are typically buried anywhere from 3 to 10 feet, depending upon frost depth threshold. Here in Cleveland, we're at about 4 to 5 feet depth. So the area of what we're looking for testing, we're looking again for physical detection, as it says here in the chart, through the ground or an entry point, which is our curb stop access. So we want a real-time indicator. So we want something that will offer a positive or negative, or being able to detect, is it lead, is it another material? So ultimately, this is going to be used industry-wide, and we want to use it during replacement seasons and at any time we need to indicate what material is. So what we're considering is the bar of success is a 90% or greater accuracy in detection within 2 test settings. Next slide, please. So testing is going to be done by invitation. It's going to be 2 parts. The first part is what we call our pipe farm. This is going to be a mock setting for basically we're going to simulate a water main in a residential area and have various connections attached to the water main. I will make it known that no water will be flowing through these pipes. They are going to have various materials, including lead, copper, galvanized, lead, copper, and galvanized, and possibly some other materials and different substrates to detect through. And the second part of the competition is going to be field benchmarking, where you will be taken to a real residential area and challenged with having to detect what the material is for the service lines in situ, so without digging up the ground. Next slide.
I'll step here in here.
Okay.
Thanks, Naya.
All right. Sure.
One more comment about the testing. So, you know, depending on the volume of responses that we get and invitees that we engage, we may be able to offer more than one round of testing. So each round of testing will include both of those areas of testing that Naya just described. But we also have a long testing period. I'll summarize this schedule here in a second. That long testing period is so that we can accommodate you, the innovator, to tweak. You know, you may do a first round of testing and and find certain things that may work in one setting and not as well in the other. And we want to encourage you to evolve your technology if you're able to do so, and come back and test if we're able to accommodate you. So just overviewing our schedule here. This is our first webinar. This is really just a summary introduction. We will have a second webinar on April 6th at 11 a.m. We're anticipating that between now and then we may get some questions from all of you, and we'll be able to address those a little bit more deeply in that webinar, and be able to engage some back and forth a little bit more as we evolve this process. Letters of intent are prerequisites for entering into this contest. Those are due April 16th. The format and what needs to be in those letters of intent are included in the request for technology, the RFT that was released. It's very simple. We just want to get a sense of, who's out there and whether you're planning to participate, so that we can also plan on our side and get a sense of, volume and kind of weighing our resources to accommodate the testing season. Proposals are due June 14th. That's a Monday. That's because, having written proposals from my own experience, sometimes you end up putting some time in on the weekend beforehand. So we want to be able to give you that. But I want to point out the gap of time here. So this is March 18th, and proposals are due June 14th. And the reason we put this time stretch in between is because we recognize that you as innovators may want to reach out and partner with other players or colleagues that you know of. You may want to, do some additional testing and so forth before coming into a more formal testing setting. So we want to give you time to really respond to the challenge at hand. It's a really important challenge industry-wide, and we're hoping that you'll be able to help us solve it. Once the proposals come in, we've got about 2 weeks where our judging panel will review those proposals, and out of those proposals, identify some that look of particular interest and invite for testing. You will hear about whether or not you're going to be engaged for testing end of June, and then our field season opens for the actual testing. This will be by appointment only. I would say that because we have these 2 different settings for doing that testing, you may want to consider essentially kind of planning for a 2-day period. Again, depending on where we are with the COVID restrictions and precautions, we'll give you more updates on this, but the testing will be in an outdoor setting in both cases. And then after the field season ends, end of August, we will be announcing a winner currently planned for the Great Lakes Governors and Premiers event in Cleveland on September 17th. Next slide, please. So I just want to overview for all of you, again, what this challenge can mean for you as a participant. So, again, this is significant market opportunity with timelines driving adoption and need from utilities across the country. And the unique opportunity here for this Open Innovation Challenge is the opportunity not only to be able to test in real world kinds of settings, but also have utilities that could be potential customers down the line actually getting to see what it is that you are evolving in your innovation. There's cash prize, media exposure, and fundamentally, high performers out of this testing season may have future testing, piloting, or demonstration opportunities, with multiple different communities as represented here, our sponsors, and beyond, because when you have utilities that are excited about something that can help solve a problem, word gets around, and Cleveland Water Alliance will be helping to promote that. So next slide, please. Quick review. If you want more information, you can see at the top here www.clevelandwateralliance.org/innovate. That site has the downloadables, the RFTs, additional information. We've got letters of intent due April 16th and proposals due June 14th. And I'll turn it back to Sam to help us with any questions and take it from there.
Yeah, we've got some questions that have come in the Q&A. The first one is, would it be correct to say that the only solutions that you're looking for are those that work in the pipe farm, i.e. something inserted into pipes that are not carrying any water? We have a solution that works, but it would fail the pipe farm test.
So I'm gonna suggest maybe Jeff or Naya or Bill take this one. So, but just to give you a quick preview, I think there's kind of two ways that on our side we're imagining a device might work. It could be something that goes into the simulated curb stop, so it can go into a pipe and detect from there, or it could detect from standing above the ground, above where that pipe is, and potentially detect through the ground. Do you want to take it from there, Naya? Or
I can take it. So just to kind of elaborate on what Evie just said, as far as the pipe farm is concerned, the reason why I mentioned that there is no water going through it is it's just a mock-up of what a water main system with service lines may appear. I know some technologies, there may be some slight differences if you have to account for different things where there's flowing water through the pipe. It's not necessarily so much that we're expecting a technology to be physically inserted into the service line, because that could actually cause a disturbance if there is lead. What we're envisioning, as Evie said, is that whether it's, a surface detection doesn't require, think like a metal detector would, something along those lines. Or we're going to have access tubes that would give access to the curb stop valve. So if you needed to send a probe down the pipe, that would give you access, to touching the service line, that would give you access that way. So it's not so much dealing with flowing water into the pipe. And we welcome all technologies. We welcome all applications, letters of intent. Show us what you have. There also will be real world testing in a live distribution system. So, I invite everybody to at least, offer an application and proposal and show us what you have, because we're very interested to see it.
Great. A couple more questions coming in. You might have answered this, Niall. Will solutions that require access to pipes from inside the home be considered? So I know you mentioned the curb stop. What about home access?
That's potentially possible. I'm actually going to toss this one over to Jeff to possibly answer on that, because he may be partnering on that.
Yeah, I think, as you mentioned in your last response, any and all technologies will be considered, and methods will be considered as well as part of the letter of intent. You made a great point, Naya, in that, if someone intends to in any way disrupt that service, most especially if you have like galvanized pipe and mineral deposits, say on the private side, trying to get through that to ultimately end up on the public side where the lead would exist. I think that'd be really concerning as a solution to the problem, simply because that disruption, by turning the water off, by running some type of sensor through the pipe, would cause a lot of water quality issues and be an issue with regards to notifications and filters and a whole number of things for some period of time until that like the orthophosphate, the orthophosphate lining reestablishes itself, which could be months on end. So I don't know that that would be a great solution, but it's once again, I would recommend that they submit the intent and we could then review it from that perspective.
Great. Couple more questions. How many measurements per day or per season need to be done? And what is the definition of real time, within minutes, seconds, same day?
I'm gonna ask whoever sent that in as far as the how many measurements, if they could offer some additional clarification, but I'll answer the second part of that question. As far as the real time, I mean, throughout the day, we want an in-field measurement. We want to be able to put your technology in the field, whether it's seconds or maybe minutes. We're looking for same day in field kind of quote unquote real time detection because we envision this technology being used, with our field inspectors who, and maybe this answers the first part of the question a little bit, in a real time scenario could be evaluating, throwing a large number out here, up to 100 connections a day, depending upon the work that they're doing. As far as the testing scenario, we're probably going to look at around in the test farm, probably about 10 connections, maybe a little more. And I would probably envision about the same as far as the testing is concerned for the in-field real distribution scenario.
I think that might answer the next question too, which is, are there time constraints for detecting yes, no for the lead? Should that be real time? So I believe that's what you just.
Yeah, basically it, like we're looking, it's probably going to be, I would think like the testing period is, it's going to be by appointment only, but you'll probably have a few hours to work out your technology. We're looking for something pretty instantaneous. We're not necessarily looking for, 6 weeks from now, what is this? Because we're trying to get to a point where, using it in a real life scenario, we need to know what that pipe is, in the ground without having to dig it up. So that's what we're looking for.
I'm going to just interject on a couple of things. So think about this in terms of how this currently works, right? So, every spring, summer, fall, utilities have their field teams going out there and with these requirements, trying to identify the lead pipes. They're on site and essentially right now need to dig up those pipes to find out whether or not they're lead. I think the goal scenario here is that, starting in the spring, perhaps utilities could send out their field team to actually do an assessment and say, okay, we've identified 10 lines in this block. And so, maybe ideally it's a positive, negative, so they can mark it on their map right then and there. But, some short period of time, since they're going to be trying to look at a lot of different service lines in a short period of time. So being able to say, within a couple of minutes at most, maybe that they're able to say, okay, this address has this material, or it's definitely lead, yes or no, is a real priority. So it needs to be fairly quick response. That said, we know this is going to be an evolution. If you have something that you feel can help with the detection, but it takes a couple of hours now, it could be that that's where we start, and there's an evolution that goes into, and maybe partnerships that can go into bringing the time period down, or vice versa. So what we're describing here is the goal, for these utilities. And, you know, and that's what this is all about, is helping to get innovators out there to focus on the challenge and what the goals are out of this. And we know that there may be an evolution to meeting that goal, you know, over the course of time. So I hope that helps.
Mhm. Yeah, I think that's a good transition to a comment that we received in regards to the pipe farm and the testing process. And they said the pipe farm test may preclude lots of solutions. Unfortunately, I recommend reconsidering how solutions are evaluated if innovation is truly valued. EB, if you want to comment on that.
I'll take a stab at that. Naya, you might have some ideas. So, you know, we're doing two parts to this test, as Naya mentioned. And, you know, I anticipate that we're all going to learn together. But the whole idea of the pipe farm is that, you know, it gives us an opportunity to provide innovators with a controlled environment, and the utilities too, a controlled environment where we know what's buried where. And knowing what's buried where and what materials there are there, plus what's on top of those pipes, you know, whether it's gravel or concrete or whatever it is, gives us a nice controlled environment to be able to see with the innovator, you know, where the device may or may not work. So it could be that you have a device that can detect the actual material of the pipe, but it works well under soil and gravel, but maybe not as well under concrete, for example. So it gives us in a small location several different types of combinations of what real world conditions might look like. The only reason that there isn't water flowing through this is because the focus is on the materials involved rather than on the operating system. The second scenario is real world, you know, pipes that are in operation. But you know, remember that in most utilities, when they've identified that a pipe is a lead pipe in the real world circumstances, they're already underway with, you know, working to replace it. And oftentimes the only way they do know where those lead pipes are, it's because they've already dug it up. So we're working on that on our end to provide, you know, kind of more of we have a benchmark map that we're able to provide the innovator with a yes or no, you kind of got it right. But it's that combination that we really thought was important for providing, you know, deeper insights into whether an innovation might work. And we, you know, we don't know what you have. So, you know, we'll take into account what, you know, how your particular innovation may or may not work in different settings. But this gives us on our side kind of a range of being able to get some insights.
Yeah, and yeah, we've got another question that came in. Can you clarify, are the pipes in the pipes farm dry, filled with stagnant water, or flowing water?
The pipes will be dry. Unless, of course, groundwater has seeped into them, but is intended that the pipes are dry. I could probably make sure that they're clamped on the end so that could mitigate the stagnant water issue.
We've got another question that came in. Can you verify the email address, please? So the email address are the letters oi-2021.lead@clewa.org, and that information is all online at the website that EB provided, cleanwateralliance.org/innovate, and in the RFT that you can download there as well.
OI, so just think of open innovation, OI-2021.
And it doesn't look like we have any other new questions that have come in. EB, feel free to take us home or gather maybe some closing statements from our panelists on board.
Any last comments from our panelists here? Any additional thoughts?
I'll just say one last thing, and this is kind of just adding to what Evie just said. You know, we want any and every solution that you have for physical detection. Show us what you have. Don't feel that you need to be limited. If you have an idea, show it to us. We want to see what it is. You know, with the pipe farm, as Evie said, it is a controlled situation, so it does take out some variability that you would find in a real world scenario, whether, you know, as far as flowing water is concerned or stagnant water if the water's off. But it does give us a small area to have some hypothetical scenarios with different types of substrate, different combinations of pipe. So that gives you kind of a good testing ground. But I saw a comment also like without water in the pipes, winners may be solutions only work in non-real world settings. That's why the contest itself is a combination of both of those things. Because as someone pointed out before, something may work better in a real world situation, which is obviously our ultimate goal, but maybe in the testing ground may fall short. But again, send us what you have. We want to see what you have. That's the whole point of the innovation.
And, you know, and remember too that, you know, part of the opportunity here is to get feedback from utilities who would be the ultimate end user. So, you know, we understand how innovation is not always a straight line, but it's a rare thing to be able to get direct feedback and ideas from your potential target market. So, you know, we're excited. We'll be engaged with you on this.
Yeah, I think it's an absolute great opportunity for a lot of potential vendors out there to be able to test their technology, have that pipe farm where you kind of simulate a distribution system, and then at an appropriate point in time actually be out and go out and do a pilot in the actual distribution system itself. And if we're looking at 90 percentile of them, you know, getting that correct, let's see if that 90 percentile goes out into the field when you go, so you do have some validation at an appropriate point in time.
That's a great point, Bob. Thank you so much. Jeff, anything you want to add?
I guess I know there's been a lot of conversation about lead and such and being able to identify lead, but as was mentioned in Naya's presentation, you know, knowing where galvanized exists and knowing where copper exists is just as important as knowing where the lead exists as well, because if you find copper, then you know there's no lead. If you find galvanized, then you know there's no lead. So I think in Akron in particular, with the rules starting to focus on what is the material of the house line, and if that house line is galvanized and that galvanized was downstream of what used to be lead, and we have over 50 years of removing these lead services, but if 50 years ago we removed a lead service and we don't know the material of the house line, having a technology that indicates that this is galvanized without having to enter the home and without, you know, looking at where the meter is located and seeing what's coming through the wall would add a lot of value to Akron, and I'm sure other utilities as well. So, but thank you for the opportunity, allowing Akron to be part of this. Greatly appreciate it.
Yeah, Jeff, not to mention the time it takes to do all that, right? It would cut down time greatly with digging that thing up for sure. So I'm excited about it. Great opportunity, and hopefully we get a lot of good feedback at the end of the day here.
Great. Thank you.
This is Verna. I just wanted to add, I agree with all of that. In Cincinnati, we're actually in the thick of doing a lead service line replacement programs, and that's probably one of our biggest challenges now, is that we end up spending a lot of money paying contractors to go replace a line. We actually had a contractor replace what was supposed to be a lead line, and they replaced a copper line with a copper line. So those types of things are happening. We're very interested in some sort of technology to help us streamline our program, and Bob, Jeff have said save time and save money and aggravation for the customers also. So thank you.
Great. Well, we're excited to see what ideas all of you come up with in helping us solve this problem. And as Sam has our next webinar up here, just a reminder, Tuesday, April 6th at 11 a.m., our next webinar, which will give us an opportunity to go a little bit deeper as you have some time to do your own research and really dig into the RFT. And we really look forward to hearing further from all of you. Thank you.
Yeah, absolutely. This webinar is being recorded. So all registrants will receive the link once we have it uploaded onto our page. It'll be accessible for anyone. So if you want to forward it to folks who weren't able to attend, it'll be available to everyone. So thank you so much to EB, to our panelists, and to you all for tuning in and for your great questions. And we are excited to see what you got. Thank you.
Thank you.
Thank you.